Hi y'all, so you need your calculator and a periodic table, and what we're going to do is we're going to walk through how to solve this problem. So let's just go ahead and read it. It says, what is the mass in grams of 1.20 times 10 to the 24 molecules of glucose? And in the parentheses I've given you the formula for glucose, which is C6H12O6. So what we want to go ahead and do is identify our given, and I'm just going to underline that right here. So our given is the 1.20 times 10 to the 24 molecules of glucose. Don't be intimidated by molecules. Remember, that just simply means a specific adjective to describe glucose, but it is a particle which is related to Avogadro's number. And then the problem is asking us to solve for mass, which mass is always measured in grams. Okay? So this is a particle to gram problem. And why that's important to go ahead and identify that thought is because we need to identify, do I need one conversion factor or do I need two? And if you think about it, particles to grams, there is no single conversion factor for that. When you add up molar mass on your periodic table, that is always grams per mole. So particles is not included in that, right? But if you use Avogadro's number, which in 1 mole of any particle, we have 6.02 times 10 to the 23 of those particles, then now I have a part of a conversion factor to use to convert here. So our pathway is going to be particle to mole to gram, which means when you see it this way, I need two conversion factors. Avogadro's number, and the second one I'll need molar mass, MM. All right, so we already know Avogadro's number. That is in 1 mole of any substance, there's 6.02 times 10 to the 23 particles. Okay. And then molar mass, for every mole of glucose, we need to add that up, and I believe it is 180.18. Oops, I'm so sorry, y'all. This learning how to use these little pens is not always amazing. There we go. So 180.18 grams. So for every mole of glucose, that's how many grams of it that I have. All right, so what we underline, this 1.20 times 10 to the 24, that is going to actually start our problem. So that's our given, 1.20 times 10 to the 23. And that's going to be particles. I'm just going to put part. Is that okay with y'all? Just to save space. Oops, I'm sorry, y'all. That was 24. My apologies. There we go. Okay, our first conversion factor we're going to plug in will be Avogadro's number because we want to move from particles to moles so that we can move from moles to grams. Now, I'm going to plug that in with Avogadro's number on the bottom because I am trying to move away from Avogadro's number. And I'm trying to move into moles, so I need that to be in the numerator, and that means these two cancel out. But let's go ahead and keep adding in the rest of our conversion factors just like we did with the years to seconds problem. So now I know that I'm going to need moles to grams, or molar mass, because I want to solve for mass, as the problem has asked me to do. Now, mole is here in the numerator. That means when I plug in this conversion factor, I'm going to place moles on the bottom and the mass in the numerator. Okay, so moles cancel out. Now, my unit that will carry through to the final answer is going to be grams. And let's go ahead and crunch these numbers here. I hope you got your calculator ready. And then multiply times the 180. Okay, I got 359.16, et cetera, et cetera, et cetera. But we always have to go back and look at our given, which is the 1.20, to decide on the number of significant figures that we would need for our final answer. And to me, it looks like we'll need 3. We have a trailing 0, or a 0 that's at the end of the number. We have a decimal place, so that means the 1, the 2, and the 0 are all significant. So I'm going to report my answer to be 359 grams of glucose, C6H12O6. Thank you very much.